Hello friends, welcome to my channel, a channel for learning simple coding. If you find this video to be helpful, please like, share and subscribe my channel. In this video for learning C for DSA, I am going to explain you the self-referential structure and the role of self-referencing structure to build a linked list. So for that I create one file here. I give the name self-reference struct.c and here I include first of all the studio.h, then I create main, and here I need to create a structure. So I create a structure. I said type def struct and I give here node as the name of this, and here I say int x and y, and here I just struct the same name node and I create this next, remember, and here I give the name to linked list. So I save this. You see that this is a simple structure. Here we have a two value of integer type x and y, and this structure having the pointer or reference of itself. This node is the name of a structure and the same structure having or pointing to the same, that is called self-referential structure. Means the structure will store the address of itself, and this structure play big role for data structure like linked list, stack, queue, and we have the new terminology nowadays blockchain, so we can implement blockchain also like that way. So here I am explaining you the role of this self-referential structure for building a linked list. Very simple concept is there, but we confuse by the some wrong examples. So we confuse by just learning a wrong examples. I am giving you here a very good example to understand this. So this is the structure which pointing to itself. Remember that the node name of this structure pointing to itself means their own address we can insert here. So for example, I create linked list. I say node 1 and I initialize this. I give the 2 and 3 value, and here I pass the null because I am not pointing any reference to this. Again I just create linked list. I say node 2 and here also I pass for example 4 and 5 and I pass null. Remember that. Then I create one more linked list. I say linked list node 3. So all these nodes I am creating here, remember that, and they doesn't have any link. Null I am passing here. You see, I save this. So all these node which I am using here, they does not have any link, but remember that they are the node of same structure. So if I want to display information of individual structure, I can say printf and I say x equal to %d, and here I say node 1 dot x. Same I can do for y also, nothing special. So I say here here I can say /n, and next line here I can say /n, and here I can say y. Okay, if I run this, it's very simple. I say gcc and I say self-referential structure, then I say a.exe. You see 2 and 3 is coming. Similarly, if I replace the value of 2 here, I can display the node 2 value. You see, it's very simple. Similarly, I can change to third. I can display third value also. That means these three are individual node. They have their individual memory. That means node 1 also have some memory, 2 also have, 3 also have, and this is null, and this means it can store the reference of itself. So I can say here that this node 1 dot next can have the address of node 2. Remember, this node 2 address we can pass to node 1. Why we can pass? Because it's pointing to itself. So node 2 is also structure node type. We can pass the reference to this. Similarly, I can pass the address of 3 into the 1 we have passed to this, An address of 3 node we can pass to 2. Remember that this is a 1. In a 1 we pass the address of 2, and in 2 we pass the address of 3. And remember that we have to secure the address 1. So I say the node address start is node 1. Remember that I just do this. So linked list, and I say start. So this is the first node, starting node of linked list that have the address of node 1. Remember that this starting point is the main in linked list. Don't lose this address, because once we lose this address, that means we will lose the address of first node, and first node will lose, then we will lose all the nodes, because first node having address of second, second having address of third. But we need to catch, and we have to just put this start in a safe zone. That means that is the starting of the linked list. So you see that just with simple example we build a linked list. Now I want to display all the informations of this by node 1. Suppose I want to display the value of node 1 and node 2. Remember that? So I can display, no problem at all. Just by this 2 and 3 is coming. Now with the help of this I say next. Remember that I say next. So this next is what? This next is node 2. So now you will see the value of node 2. We have okay, this is pointer, so I need to use this one also because it's a pointer. We forget to use pointer here notation. Save this, and you see that with the help of this, with the help of node 1, I reach to the node 2, 4 and 5. Similar to this, I can reach to, you see, node 3. Remember, now I can reach to node 3 also. You see, node 3, because this next is third node. Once again I just compile and run. You see 6 and 7. So this node is the node 1, this next is node 2, this next is node 2, this next is node 3. So all are just linked together with node 1. So in place of this I can also use for loop to do this, or while loop. So I say while, remember that I create one more node here. I say linked list, and I say temp, and I pass here address of start. Remember that this start I have to send here, the value of the start node that we have to pass here. This start I need to pass the address of node 1 to temp. So I say here while temp not equal to null, we reach to the null state, then we need to print the value of this. Remember that I just paste this, and here I only give node 1 and node 2 like this way, and this is temp. So I say temp, I say temp, and I say temp equal to temp dot next. So I am just changing it value, try to execute it. We have the problem here because it's a pointer, so we point this not equal to null. So I say temp is not equal to null. Starting problem, so I remove this, I pass this, you see that, and I say a dot this, and you see that all the value we have a scroll here. So I can say here node 1, node 2. So first I say here, I say printf, I say node, here I say %t, here I say I, and here I say int I equal to 0, and I say I plus plus. So I plus plus would be like this, I plus plus, So that information I will display node 1, node 2, node 3. So we have before printf semicolon, I need save this, and you see that we have node 1, you see node 1 x equal to this. So after this I say slash n also, and I just compile and cls and run it. You see node 1 x and y, node 2 x and y, node 3 x and y. So like this way we can display all the information by using single one variable is of node type, same structure type. We are passing the address of first node. This address we have to preserve because it's a important address, and we check this value to null, and one by one we are traversing, this information is coming. And like that way we can understand that with the help of self-referential structure we can create indivisible node, we can link these node, we can traverse these node, and we can build and form a simple linked list. To understand that self-referential structure is very important to build linked list. I think you understand here self-referential structure and how we can use this for building a linked list. If you like it, please do subscribe. Thank you for watching this video.